So before we go over examples involving logistic models, we do need to understand what a logistic function is. And so here's my most basic form of a logistic function. We have C over 1 plus AE to the negative BX power. So the reason that this is in module 3, all about exponentials, excuse me, it does have an exponential component in there, right? That E to the negative BX power. You're always going to have some constant, some C up at the top, and we are going to kind of place a lot of focus on that. That is called the limiting value or the upper limit. Other books call it other names like carrying capacity, but this book and your homework is going to refer to it as either limiting value or upper limit. So whichever terminology they use, they're asking for what this number is up at the top. Now, when we have logistic models, we can have two different types. We can have a growth or a decay, just like with exponentials. When we have a growth, it's going to start growing slowly, shoot up in the middle, and then kind of start leveling off. When it is a decay function, it's going to be a decreasing function. So it's going to start decreasing slowly, decrease really quickly in the middle, and then again, level off. These both have the same kind of restrictions on the Y on the range. Both of these have a vertical asymptote, or sorry, a horizontal asymptote at Y equals 0. So whether that's where it starts or where it ends. And then the other horizontal asymptote is going to be at that limiting value or upper limit, that Y equals C. So whatever that number is up at the top, that's either what it's going to approach, where it starts leveling off, or where it starts right there. Now, the homework isn't going to be too bad, so we only have 2 examples to go over this. But I do want to kind of emphasize that these are very not realistic. I don't know the word I'm looking for. Applicable, okay, functions. 2020, we just went through something that could be modeled by this when we went through COVID. Okay, and not just COVID, but during flu season and anything like that. When COVID hit and it came to the US, we heard about a case over here in Washington, heard about this random case in Oregon, and then all of a sudden, more people started having it and the cases started increasing. Then during the height of this, when this increase is really bad, now everybody had it, right? Your people at school had it, your brother's friend had it, your barber had it, your aunt's cousin had it, you know, then your mom had it, then you got it, right? So here everybody's catching it. Everybody knows somebody that has it. But then we start getting immunity. We start getting the vaccine. It starts running out of new hosts. And so then it starts leveling off. Whatever the amount of people in the United States are, that's not carrying capacity. That's the maximum number of people that can have it. Kind of similarly, we're talking about, like, let's say, deer population. I don't know what eat deer, so let's go antelope population. Okay, if my antelope population starts really high in Africa, and then all of a sudden we release a new herd or a new pride of elephants, or not elephants, lions. Okay, all of a sudden those lions are hungry. It's going to eat 1, it's going to eat 2, it's going to eat 3. As those lions are populating and making more lions need to eat, and all of a sudden that antelope population is going to dip down, but it will not hit 0. Okay. So that's kind of the basis of your logistic functions, growth and decay. But these are very applicable functions that we have. So example 1, we need to graph this. Now it's using t instead of x. So this right here is my x min, and this one right here is my x max. What they don't tell me are my y min and max. But we know what those asymptotes are. So then my y min will be 0. It doesn't matter if it's growth or decay. That's going to be the bottom number. And then my y max is going to be whatever my C is. So my C here is 1000. Okay, so let's get into Desmos. And I am going to use function notation to make these two here very easy and straightforward. Okay, so I'll type this in. And I'm using X and not T. Okay, we'll change our viewing window. We're going from 0 to 15. We'll do a step of 1. And 0 to 1000, we'll do a step of 10. Okay, so here is my logistic model here. All right. Now, part A wants us to find f of 2. So since we have already used function notation, we can just do f of 2. And then for part B, f of 5. So f of 2 doesn't say how to round. Let's go to 1 decimal. Well, let's go to 2 decimals. What are we going to do? We're going to go to 3 decimals. This is 4.1979. Or if we went to 1 or 2 decimals, that'd be 402. And then this one, if we go to the same 3, would be 909.107. Okay. Is this function increasing or decreasing? Very clearly increasing. And what is the upper limit? My upper limit is C. So here, C is 1000. These answers, these questions are going to be pretty easy, to be honest with you.